Alright, this is an overview of radicals for those of you still struggling, okay? So first, I'm just going to give some pretty complicated examples of simplifying radicals, okay? I guess the very basics are simplifying the numbers, alright? So let's just do the cube root. Let's start with square root. Let's do the square root of 125, okay? So basically what I'm looking for things that break down into perfect squares. And the reason I want to do that is because if it's still inside the radical, then it's not simplified. Okay? So I happen to know off the top of my head that 125 is equal to 25 times 5. Okay? Which means I could then rewrite my radicals as square root of 25 times the square root of 5. And I know that the square root of 25 is going to be 5. So 5 square root of 5 would be the square root of 125. But let's say off the top of your head you don't know that the perfect squares is something breaks down into. Alright? That's where we can do our factor tree. And the idea of this is that we get it broken into prime factors so we can look for groups. Okay? So the smallest number I know that breaks 125 down is 5. Okay? 5 is prime, so that's good. When I divide it by 5, alright, I have to do 5 times 25 to get the other edge of my tree branch, okay? From there, I know that 25 breaks down into 5 and 5, alright? Now, since this is a square root, okay, we have like the invisible 2 out here, this is a square root, that means I'm looking for groups of 2, okay? A group of 2 is able to leave the radical and help it simplify. So, here I see that I have one group of 2 5s. All right, so 5 is going to come outside the radical. There's only one group of them. And what's left inside is the other end of my tree. Okay, once I've made my tree, I have to disregard everything but the ends of my tree branches. Okay, so 5, 5, and 5. Left over is 5. 5 square root of 5. Okay, now let's say that we're doing something like the square root of 81. Okay, let's break 81 up. Alright, that's 3 and 27, 3 and 9, 3 and 3. Okay, so ignore all this stuff now because I have my tree branch ends. I am looking for groups of 2. Okay, so here's a group of 2, here's a group of 2. Okay, that means I have one group of 3 coming out. And everything is getting multiplied together here. There's no adding the pieces, all right? This is all multiplication. So this is exponential multiplication. There's no addition going on, okay? So I have the 3, and then here's my other group of 3, so 3 times 3. And I have nothing left here, okay? So nothing is going to stay inside my radical. So that means that this is simply 9, okay? Which we know, 9 times 9 is 81, okay? So what if this was a cube root of 81, okay? Instead of my groups of 2 over here, I'll be looking for groups of 3. So here I have 1, 2, 3. Let's go ahead and circle that. I have one group of 3, okay? So that means I have a group of 3 3s, so a 3 is going to come outside. I have one of those groups, so that's like 3 to the first. And what's left inside is this lonely 3 here. Okay, you can't drop this piece, otherwise you've changed the meaning of the radical. Okay, so that's kind of if it says 4th root of 81, then you're looking for groups of 4, and 1, 2, 3, 4. There you go. All right, that'd be one group that's equal to 3. That's all. All right, so that's the basics of simplifying there. Now what I want to do is I want to look at what if we have exponents, so variables, sorry. Okay, let's go ahead and just do 7th root of this, alright? So I'm going to do the 7th root of x to the 7th, y to the 10th. Now what I'm asking is, I'm looking for groups of 7. So if you want to break x to the 7th down really obnoxiously, okay, I can take an x out, leaving me with x to the 6th. Take an x out, leaving me with x to the 5th. X out, leaving me with x to the 4th. X out, x to the 3rd, and x and x squared, and then x and x. Okay, so what does that leave me with? Cross out. So the third's gone. Okay, I'm looking for groups of 7. So 1, 2, 3, 4, 5, 6, 7. That's all of it. Okay. really tough. Okay, basically all of it, okay? So I have a group of 7 there. So that means that I get to pull an x out. Just one, okay? Now y to the 10th. You could probably guess that there are 10 y's there, okay? So when I'm saying how many groups of 7 are inside of 10, that's the same thing as division. So I can take my exponent here and I can divide it by my root, right? Which is where my rational exponents come from, right? This is the same as x to the 7 over 7, y to the 10 over 7, okay? Now, in order to see what comes outside, I need to see what do I have, how many groups, okay? So that's one group of y coming out. And then how many are left after I take 7 away? Well, there's 3 left. So 7th root of y to the 3rd. We had no x's left over, but we have 3 y's. So the 3 y's have to stay inside the radical. Alright, so those are our simple things. So now let's go ahead and try some complicated examples. Okay, so we're going to simplify these two things, okay? Now remember, multiplication, this is all multiplication going on here, okay? Exponents are just a shorthand for multiplication, okay? So I want to break down what I have in here. I have a square root, so I'm looking for groups of 2. Well, 4 breaks into 2 and 2. So that means that I have a group of 2's coming outside. So I already have this 3 out here, and now this 2 from the 4 is coming out, okay? Then x's. I have no x's out here so far, okay? It's all being multiplied together, right? How many groups of 2 do I have inside of 4? Well, 4 divided by 2 equals 2 with nothing left over. So that means that I'm getting an x squared outside of my radical sign, okay? Then, y to the 9th, okay? How many groups of 2, how many pairs of y's are there within those 9 y's, okay? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? 1, 2, 3, 4. 4 pairs of y, okay? Plus the y we already have out here, so times another y, okay? Not plus. You add the exponents, right? So this is the same thing as doing 9 divided by 2. That gives me 4 with a remainder of 1, okay? So this y is going to be left inside the radical, okay? Now z to the 18th, I don't want to write out 18 z's, okay? So I can just do my shortcut. 18 divided by 2, what's that equal to? 9. So I have a z out here already, and then I have 9 z's that are going to escape the radical sign, okay? What's left inside? That came all out, that came all out. This was left with 1 y, and there are no z's left in there, okay? So now we got to simplify. Just multiply this all together. 3 times 2 is 6. X squared, y to the 4th times y is y to the 5th, z times z to the 9th is z to the 10th, and I have the square root of y. Easy enough, okay? Over here, I'm looking for groups of 4 now. Nothing else is changing, okay? 81, let me break that down, gives me 3 and 27, 3 and 9, 3 and 3. I'm looking for groups of 4, so I have 1, 2, 3, 4. So I get a 3 that's going to come outside. So I already have the 6 multiplied by the 3 that just moved out. All right, x to the 10th, doing 10 divided by 4. I know it goes in 2 times with a remainder of 2. So an x squared will get to come out, right? There's my x squared. Okay, and 2 are going to be left inside. So I'm just going to label that x. Now, 16 divided by 4 is just 4, okay? So I have a y to the 4th coming out front, all right? Now z to the 3rd. 3 divided by 4, it goes in 0 times with a remainder of 3. So that means we're going to have 3 z's that are going to stay inside my radical here, okay? So let's put it all together. Don't forget to label what type of root this is, okay? 81, that all came out. X to the 10th. I was left with 2 x's in there, so x squared. So that's 2 x's, not x plus 2, not x plus x. It's x times x, so x squared, okay? All the y's came out, and none of the z's came out, so they're all staying in there. Multiply what we got, 18 x squared y to the 4th times the 4th root of x squared z cubed. Boom! Alright, this is going to be a long video, so if you have got the simplifying stuff, this is the last simplifying I'm going to do. We use simplifying for the rest of it, but now we're going to do adding, subtracting, and multiplying, dividing. Okay? So, here we go. Alright. First, let's do multiplying and dividing. Okay, so we have 3x square root of 7 times 4z square root of 21. So, upon first glance, nothing here simplifies. Okay? When we multiply, we're going to be multiplying the outside pieces and then our inside pieces. Okay? So I have 3x times 4z gives me 12xz. And then inside I have 7 times 21, which is 147. So now it's time to see, can we simplify? Alright, so I'm going to go ahead and do my factor tree here, 147. Okay, I know that 7 is at least a factor, leaving me with 21, and then 21 breaks into 7 and 3. Since these are square roots, I see that I have a pair of 7s, so that means these 7s are going to come outside. So I have 12 times 7 times x times z, and what do I have left inside? 3. Okay, so 12 times 7 gives me 84, square root of 3. I'm done. Okay, so what didn't simplify before simplifies now. So you have to multiply them. You have to multiply them and see if it simplifies. Okay? Division is very similar. You're going to divide first and see what happens. Okay? Now, let's say I have this problem. 7y square root of 35x to the 5th. And this is all going to be divided by square root of 5x. Okay? This looks complicated. I could take some of the x's out, but what I'm going to do is I'm going to combine first, simplify, and then I'm going to simplify the radical. Okay? So this turns into 7y times the square root of 35x to the 5th over 5x. Okay? So basically the rule for multiplication is a times square root of b times c squared of d equals ac square root of bd. Then you simplify. Division is a square root of b over c square root of d equals a over c square root of b over d. Then you simplify. Then you simplify, okay? So let's simplify here. 35 divided by 5 gives me 7. X to the 5th divided by x gives me x to the 4th. Now 7, that's not going to simplify. I'm still going to be stuck with that when this is all over, okay? And just for fun, let's toss a 4 in here, okay? So, alright, so the 4 is still there. That doesn't simplify, okay? That's still in my denominator. But up here, this x to the 4th will simplify. So my last step is 7y over 4, okay? I just leave that, just like fractions, okay? It's nothing new. And then x to the 4th, that's going to come out as an x squared, and left inside is 7. Okay, so that's my final answer. Alright, now just real fast, let's go on to adding and subtracting. Okay, so adding and subtracting, a square root of b plus c square root of b is equal to a plus c square root of b. Okay, we're going to treat these just like terms, okay? I can't add 2x plus 3y because x and y are different terms. So here, but I could add 2x plus 3x, right? That's 5x. I'm adding up the coefficients. How many x's did I have? I have 5 of them, so I have 5x, okay? That's what's going to be going on here with our addition and subtraction. So I have 2 square root of 75 plus 4 square root of 100 plus 6 square root of 27. Okay? So what I want to do is, upon first glance, I can't do anything with this, right? I have no like terms. But you need to simplify to see if you're going to have any like terms. Okay? So first things first, let's break down 75. Okay? Off the top of my head, I'm saying 3 and 25, 5 and 5. There's my group of 5. So I have 2 multiply what's popping out, which is 5. Left inside is my lonely 3. Okay, square root of 100 is 10. So here I have 4 times 10. And then here I have 27. Let's break it down. 3 and 9. 3, and 3. There's my group of 3. 6 times 3, square root of my lonely 3 left inside. Well, miracle of all miracles, look at this. We have a 3, we have a 3. We can suddenly combine some stuff. So if you stopped right here and you're like, Ms. Amma, that's not working for me, you were wrong. You got all your points off, okay? So 2 times 5, 10 square root of 3, plus 4 times 10 is 40, okay? These are not like terms. This does not have a square root of 3 on it, so they don't combine. It's as simple as that. 6 times 3 is 18, square root of 3, okay? So I have square roots of 3, 10 plus 18, 28 square root of 3 plus 40, okay? 10 plus 18 is 28. I keep my square roots of 3. That's saying I have 10 square roots of 3 plus 18 square roots of 3. So that means I have 28 square roots of 3. Okay. Now, what if one of these was a subtraction? Okay, so say we had 2 square root of 75 plus 4 square root of 100 plus minus 6 square root of 27. Okay, I do it the exact same way. Okay, I simplify. So I saw that that was 10 square root of 3 plus 40. Now this would just be minus 18 square root of 3. And now combine my like terms. I had 10 square roots of 3, and then you took 18 away, leaving me with negative 18 square root of 3. 40 is left alone. There's my answer. So that's radicals. If you're confused about something, either ask me or ask me in class. Come see me. Or rewatch this video. Alright? Hope this helps. Thanks.